Set theory can be defined as a collection of well-defined objects. Let me write that. Set can be defined, or a set, put it that way. A set can be defined as a collection of well-defined objects. We said object, that doesn't mean it always has to be object you can touch, okay?
Okay.
Okay. Yeah, for example, example, we can have a collection of shoes, okay?
Mm,
Maybe different kinds of shoes, or a group of colors, maybe orange, yellow, blue, and so on, or the months of the year, okay?
yeah.
Or you can also have, let's say, the multiples of 9, okay?
Mm-hmm.
Or we can say all even numbers. Let me start with all odd numbers from 1 to 100. 100. Or we can say all the factors of 60. Or we can say um, all even numbers from 2 to 60. Or we can have uh, capitals, we can even have a set of alphabets, okay?
Mm-hmm.
The group of English alphabets. Alphabets. So we can have various, groups, various well-defined. When we say well-defined, we mean a group has a different meaning from the other group. Okay,
Mm-hmm.
so that's what makes them well-defined from another object, well differentiated from another object, well explained, well stated from another object. So the group of English alphabets. Otherwise, we can still have uh, all the vowel in the English alphabets. Okay, alphabets, or all consonants from B to Y. All consonants that exist from B to Y. Okay, now looking at this, is there any of these sets that you think will be related in one way or the other to another set? Look at it, Human, and tell me.
What's the question?
Yeah, read the
What's the
definition.
question?
Wait, read the definition first. Read this definition of set.
It's, a set can be defined as a collection of well-defined objects.
Good. Well-defined objects simply mean objects that are different from other objects, okay?
Yeah.
That you cannot confuse them, with another object. Is that clear?
Yeah.
Can you confuse a group of a collection of shoes with a group of
Yeah.
colors? No, you can't confuse them together. Okay,
Yeah.
and you cannot confuse the multiples of 9 with all odd numbers from 1 to 100. No, those are two different categories. Is that clear?
Yeah.
In the same way, all factors of 60 are different from all even numbers from 2 to 60. Then, the group of English alphabets are also different, even though they're related to the vowels in the alphabet. The same thing with all consonants. So, but I'm now asking you that even though I said they are different, is there any of these groups that are related to another group? That's my question. Yeah, Kira.
Mm.
Check all of them.
Repeat it. Can you repeat it?
Yes, I said, is there any of the groups? Is there anyone that has anything in common with any of the with another one?
Um. mm, It was
For
maybe
example,
all even
okay,
numbers.
yeah, yeah.
Maybe all even numbers from 2 to 60 and all factors of 60.
Good, because there will be some factors of 60 that are even numbers. Okay,
Yeah.
so they will have something in common, and yeah,
And
that's
maybe
right.
all odd numbers.
Maybe all odd numbers from 1 to 100 and all multiples of 9, because 9 is an odd number itself. Okay,
Yeah.
so there will be multiples of 9, there will be odd numbers. Okay,
Okay.
so they have things in common. So that thing that is common to them is called intersection. It's called what? Intersection.
Interception.
Intersection. Intersection. So now we're going to move on. Let us look at an activity. You know, let's assume you've been asked to work in pairs with your students, okay? With your fellow
Yeah.
students. Exactly. So work in pairs and oh, I said work in Paris. Work in pairs. Pairs. Okay. Switch this iris. Okay. IRL. Work in pairs, then collect different colors of flowers, each by each pairs, and construct set from those flowers. Okay,
Okay.
based on their colors. Based on what
The colors.
colors? So let's assume you and set of colors collected by somebody. Okay, then set of color collected by another person. Is that clear?
Yeah.
So let us look into that. Let's say we have Sophia, or let's say I have John. So set of colors collected by John is we have J for that. Okay, is that clear?
Yeah.
We have J for that, and those are the colors: red, yellow, blue, and pink. Okay,
Mhm.
so if I say red, it's collect red, collected yellow, it collected blue, and pink. That's the set of colors collected by, let me use this rose as pink. Okay,
Okay.
collected by John J. Then another one set of colors can be collected by another person. Let's say, holding place. Um, trying to look at the set of colors collected by another person. Let's say collected by Root. Okay.
Okay.
I also collect yellow. Root. Let me say, and some other set of colors. So let me say. So set of colors collected by Root are these colors. Okay,
Okay.
which are the first is yellow collected by Root, and white and blue and purple, okay, orange and red. So these are two people working in pairs, okay?
Mm-hmm.
Two students working in pairs. So the first person collected some colors and the second person collected some colors, right?
Yeah.
Okay, let me try and put all of those colors on one line so that you can see them. So by John, we have these colors. Okay,
Yeah.
and collected by Ruth, we have these colors. So there are some questions we'll try to answer. So these are sets, okay? These are example of sets. Is that clear?
Yeah.
Good. Now, we have to construct some sets based on the above sets, okay?
Mm-hmm.
Say, construct the following sets based on the two sets above. And what are the sets we want to construct? The first set that we're trying to construct will be the set of colors of flowers collected by John or uh, John or and Ruth or both of them. Okay,
Uh-huh.
yeah, by John or Ruth. Okay, or both of them. So if we want to do that, we have to look into the data. Okay,
Mm-hmm.
have to look into the data and figure out this set A. So set A now is going to be, let me see, yeah, set A is going to be equal to this, which is set of colors collected by John or Ruth or both of them. So can you look at it and tell me those colors? We have red, right, collected by them, right?
Yeah.
Red. Which other color? Yellow,
Yellow.
right?
Blue.
With red, then yellow, then you said blue, right?
Yeah. Pink.
Pink.
Orange.
What about white?
I said orange.
I mean, what about white? Since you have
Yeah,
seen
white.
the second white first, okay? Then purple, right?
Mm-hmm.
Purple. And which one again? Orange, right?
Or orange, yeah.
Orange. Then enclose the set. So this information that you've gathered in A will be regarded as union of set, okay?
Okay.
So this is equal to this is equal to um, J union R, okay?
Okay.
Union union R, J union R. That is combination of both J and R. Is that clear?
Yeah.
Without repeating any of the colors. If you look at it, how many colors did J collected? That's one, two, three, four. Four colors, right?
Yeah.
How many colors did R collected? How many colors?
One, six,
Six. What is six plus four?
10.
But do we have 10 in their combination?
One, one, two, three, four, five, six. No, I have seven.
We have seven. Why? Why is there a difference in it? Because we did not repeat what they both are, okay?
Okay.
That means there is a three that is common to them. Can you figure out which three colors are common to them?
Yellow, red, and blue.
You understand now?
Yeah.
So let us look at our second activity. Maybe that is going to be. So second activity says set of colors collected by John or and Ruth. Okay, John and Ruth.
Okay.
That is common to them. So that's going to be the second activity. So um, B will be set of. Okay, that's small B now. Question B. So that will be set of colors collected by and Ruth. Okay, is that clear?
Yeah.
So set of colors collected by John and Ruth. Now, that means we are trying to look for what is common to them. So we're going to name that set B. So set B is going to be equal to, what are those colors again? Red is common to them, right?
Yeah.
So we pick red. Which other color? Yellow. We pick yellow.
Blue.
And lastly, we pick blue, right?
Yeah.
So that is the intersection. So this is going to be equal to the intersection, which is J intersection R. Okay?
Uh-huh.
J intersection R. So I'm going to write that. So let me say, let me put them together now. So that accounts for the difference in that number value. Okay?
Okay.
Now, here, let me move this down a bit. And I'm going to write something here that GUR reads GUR reads J union R, okay?
Okay.
While the other one is going to be that JNR, okay? That
Yeah.
is J intersection R. So JNR reads J intersection R. So what does intersection mean? It means what is common to the two sets, right?
Yeah.
And what does union mean? It means the combination of them all, okay?
Hmm.
Okay. Now, before we round up this aspect, we want to look at other kind of question that will come under this. We can say set of colors collected by um, root only, okay?
Hmm.
So let me see. Set of colors collected by root only, that is only root. So what do you think that should be? That set of colors that John did not collect but root collected.
Which one's root? Um, yellow.
Wait, set of colors that root collected but John did not collect.
Root.
Yeah, that root collected but John didn't collect. So root collected yellow but John did,
White.
okay? Yeah, white, now you're getting it.
White. Purple.
And what?
And orange.
Good. So that is going to be set C now. Set C is going to be white, purple, and orange, right?
Yeah.
White, purple, then orange. Orange. That will close that set. Is that clear?
Yeah.
And this, we can regard it with another name in the future of set theory. So we're going to look at it later. Then, set of flowers, set of colors of flowers, except the ones collected by John. Okay,
Yeah.
that's the next one. So the next set is set of all the colors except the ones collected by John. So set of all the colors. Where is set of all the colors? This one, union, okay?
Hmm.
So let's take it down there. If we bring this is set of all the colors, okay?
Yeah.
So this is all of the colors. This is all the colors. So if we want to mention all the colors and we don't want to mention the ones that John collected, what are we going to mention? Let us bring what John collected, okay? So where are the colors of John? They are here, right?
He collected red, yellow, blue, and pink.
Yeah, so the question says, what is in the all of the colors that is not in John? So that will be our set D, okay?
Okay, so white,
Hold on. So D equal. So now you can name it, yes, white,
white, purple.
purple, right?
Yeah.
So white, then purple
Then orange.
and orange, right?
Yeah.
Orange. That's clear, right?
Mm-hmm.
Okay. So with that, what name do we then give to this? We can say we can call it J prime, okay, or J complement. That is complement of John. What we complement John to make the universal. Okay?
Okay.
So this is J prime or J prime, which reads J prime, J prime, or we call it J subscript superscript C to the end. So J complement, like something of this nature, J complement, which also reads J complement. Okay?
Mm-hmm.
So with that, we've been able to look at the concept of set theory. Okay? So you can start putting them down. Once you're through, we're gonna move on. Okay?
Okay, so don't write all of it down.
Yes, put everything down. Okay?
Quick, I get a new book because my book's finished.
Okay, okay. That'll be good. So,